All right, good morning and happy Monday. So, we're going to go over lesson 7 today. This week we're focusing on lessons 7 and 8, but you can find those assignments in this folder. And then today we're going to go talk about lesson 7. So, you have some time to sit on this and think about how you're going to approach this assignment. So, I'm going to click it, and then we have this PDF. So, to warm up, we have some instructions on how to actually form these chemical formulas. But first, let's fill in this box. So I've made a document with this box, and we're going to talk about taking an element, figuring out how many electrons it has, how many valence electrons it's going to have, and then the ion that it forms. So I have that here. Let's start with potassium. So we got to find potassium on our periodic table. So here we have potassium. We find it right here. Chemical atomic number 19. So if it's a neutral atom of potassium, it has to have the same number of electrons as protons. So we know that it has 19 total electrons. So we have 19. Now we think about valence electrons. So this is where using the periodic table really is important. So these groups or families are organized to tell us exactly how many valence electrons a given element has. So these first two, think about these numbers, right? 1, 2. So this family, the alkali metals, has 1 valence electron. These have 2. Over here, we have 3, 4, 5, 6, 7, and 8. Remember the octet rule? The noble gases have 8 valence electrons, so they don't want to do any chemical reactions. They're already happy. But everything here, take the second number, 7, 6, 5, 4, 3, 2, 1. So we know that potassium has 1 valence electron. 1 valence electron. That means for potassium, it's much easier to get rid of that 1 valence electron instead of taking 7 in, right? So we want to think about what is the easiest thing for these atoms to do. It wants to get rid of those. So when you get rid of an electron, you're getting rid of a negative charge, and you're going to form a positive cation. Let me show you here. So see here, potassium is going to be K1+. All right? That's the ion that it's going to form. So I'm going to type the chemical symbol, K, and then I press Command right arrow on my computer, 1+. There we go. Let's do it for the rest of them. Iodine. So we are going to find iodine on our periodic table. It's over here. It's a halogen, so it's going to be 53 electrons, but 7, because it's in this row, 7 valence electrons. All right? So 53 total electrons. 7 valence electrons, and because it's much easier to take in an electron than get rid of its 7 valence electrons, remember it wants 8. Over here, if you get rid of 1 for potassium, that will give it its next shell is 8. So we're going to take an electron, and it's going to take in a negative charge. So we have iodine, I'm typing 1, I, and then a 1 minus. Let's do that for phosphorus. So phosphorus is in this row, 15 electrons. It's going to have 5 valence electrons. 15, 5 valence electrons. It's easier for phosphorus to take in 3 more electrons, right? Because 5 plus 3 equals 8. It's easier to take in than get rid of. So it's going to form a -3 ion. So phosphorus, my goodness. Phosphorus 3 minus. And then lastly, for magnesium, let's go check that out. Magnesium is over here, 12 electrons. So magnesium 12 has 2 valence electrons, again because it's in this row. And then we're going to form Mg, and then it's going to be a +2 charge because it wants to get rid of those negative charges. 2+. There you go. I'm going to go over the crisscross method in the next video and show you a couple examples.